Kuzuzangpo, we welcome to Bhutan e-learning program. I am Balbadur Gurung, working as teacher at Loseling Middle Secondary School. So today I'm here for Key Stage 5, particularly for classes 11 and 12. And the topic that we'll discuss today is on Chatellier's principle in close reference to chemical equilibrium. So let's look at the objective. So today you will be able to define chemical equilibrium. We'll also look at stating Chatellier's principle, look at different factors that affect chemical equilibrium, and finally the application of Chatellier's principle. Before we really move into our lesson, I have a short analogy for you, so let's look at it.
Original example of you digging a hole and your friend refilling it simultaneously. If you start digging at a rate faster than refilling, the hole gets larger. In order to maintain a constant size of the hole, your friend must work harder to fill it faster.
Okay, dear students, how can we keep the size of the hole constant? Yes, the size of the hole is going to remain constant if the rate of digging and the rate of filling are equal. And this state is known as equilibrium. So now, let's be specific. What is chemical equilibrium? And to understand the word chemical equilibrium, first you should understand two reactions, irreversible reaction and reversible reaction. So let's see what is irreversible reaction. So irreversible reaction, it is a reaction in which reactants are completely transformed into products and that product cannot be reversed. So this type of reaction we call it irreversible reaction. For example, burning of LPG gas is an example of irreversible reaction. Once your LPG gas gets exhausted, so which means you cannot get back the LPG gas. So for that you will have to go and find the new one. So what happens here is actually LPG gas, it is a mixture of propane and butane, and this hydrocarbon actually burns with oxygen to produce carbon dioxide and water vapor. So which means carbon dioxide and water vapor cannot give us the hydrocarbon. So that is why this is a good example of irreversible reaction. So next important reaction that you need to understand is reversible reaction. So reaction in which reactants form products, and again the products actually react back to give the reactant. So this type of reaction we call it reversible reaction. For example, you have hydrogen and iodine reacting. So hydrogen actually it is colorless and iodine it is violet, and the color, the violet color that you see in conical flux is due to iodine vapor, and hydrogen and iodine react to give the colorless compound hydrogen iodide. And if this reaction is irreversible, one directional, then what should happen? The hydrogen and iodine should react, and what is left now? You have hydrogen iodide which is colorless. So the color inside the conical flux should become colorless, but here only the intensity of the violet color decreases. The color, the violet color actually remains same, and this indicates that this reaction is an example of reversible reaction. So in fact what happens is hydrogen and iodine react to give us colorless hydrogen iodide which is forward reaction, and again there is a backward reaction, reverse reaction, hydrogen iodide breaking down to give hydrogen and violet iodine. So you can also represent together one arrow that tells us about the forward reaction and another arrow that tells us about the backward reaction. Now, what is chemical equilibrium? Let's look at the same reaction. What is happening here? Hydrogen combining with iodine to form hydrogen iodide. And since the reaction is reversible, hydrogen iodide breaking back to give the reactant. So is the chemical reaction at equilibrium? Yes? No, isn't it? The chemical reaction is not at equilibrium because the rate of forward reaction is greater than the rate of backward reaction. Now again, let's see at the same equation, same thing happening. There is forward reaction taking place as well as the backward reaction. Now is the chemical reaction at equilibrium? Yes. This is because the rate of forward reaction is equal to the rate of backward reaction. Both the speed of the forward and the backward reactions are equal. That is why the concentration of the reactant and the concentration of the products also becomes equal. So now let's define what is chemical equilibrium. Chemical equilibrium, it is the state of balance. It is the state of balance in which the rate of forward reaction is equal to the rate of backward reaction, and in this the concentration of the reactants and the concentration of the product actually remain constant. So now actually we have very important applications of chemical equilibrium. Everything in life needs to be balanced. We need to be at equilibrium, and the importance of equilibrium I will explain you later. So before that, let's go through the Chatelier's principle. I think you have seen this equation last year in class 10. If you are in class 11 today, so this reaction, this process actually comes from Haber's process. So Haber's process, we prepare ammonia, and ammonia is one important compound that is used to manufacture different nitrogen containing fertilizers, and because of ammonia now it has contributed significantly in the field of modern farming, modern agriculture. So here what happens is Mr. Haber, he was the first person to prepare ammonia. He was preparing ammonia from 1 mole of nitrogen and 3 moles of hydrogen. And he combined this, and it gave us 2 moles of ammonia at a time. But what happened? Since the reaction is reversible, the ammonia that was converted actually got back. The ammonia that we have actually reacted back to give hydrogen and nitrogen. This actually stressed Mr. Haber. Haber actually wanted more of ammonia, but here what happened was the product, the ammonia that he actually prepared was getting back to the raw material. So he was actually very stressed. Due to this, so there was a loss of effort, wastage of time, and the resources for Haber's. And this is where the Chatelier's work contributed and made many people actually happy. So Chatelier, he is a French chemist, and he is actually well known for his principle, Chatelier's principle. And he found out that if we add stress, or if the reaction at equilibrium is disturbed, then new equilibrium will be established. The system will nullify the stress. System tries to actually overcome the stress by establishing the new equilibrium. For example, let's look here. You have two tanks filled with water and connected to one another. The system is at equilibrium. Now let's try to stress the system. Let's try to disturb the equilibrium by adding some more amount of water in one of the tanks. Now what happens? The equilibrium is disturbed, and this system will reestablish the equilibrium by shifting the equilibrium. So this is how the equilibrium will be reestablished. So in terms of chemical reaction, once the reversible reaction attains the state of equilibrium, the concentration of the reactant and the concentration of the product becomes equal. So now if we add stress, meaning if we add some more amount of reactant, or you can also remove the product, then the concentration is going to change. The equilibrium is stressed, and the system will overcome the stress by shifting the equilibrium in forward direction, or it can be also backward direction if you have added the product instead of the reactants. So therefore, Le-Chatelier principle states that when a system under equilibrium is stressed, by external factors such as change in concentration, pressure and temperature, equilibrium is going to shift in such a direction so as to nullify the change imposed. So now let's look at the stresses, or let's look at the factors that affect chemical equilibrium. So change in concentration affects the chemical equilibrium. For example, let's say this solution has attained the state of equilibrium, and the equilibrium will be disturbed if we change the concentration by adding reactant or the product. Another factor is change in pressure. So if you change the pressure, actually pressure is inversely related to its volume. If the volume becomes smaller, then pressure actually increases. And the next factor that we have is change in temperature. So I will explain in later part of my presentation how this stresses actually influence the chemical equilibrium. So let's look at the first stress. So you have ferric chloride reacting with ammonium thiocyanate to give dark red ferric thiocyanate and ammonium chloride. So here what happened is you have ferric chloride and ammonium thiocyanate reacting and giving us red colored ferric thiocyanate and ammonium chloride. And since the reaction is reversible, so ferric thiocyanate and ammonium chloride reacting back and giving the reactant. And this process will continue, and the time will come when the concentration of the reactant and the concentration of the product becomes equal. For example, now let's say the system has attained the state of equilibrium. Let's say A is our ferric chloride, B is ammonium thiocyanate, C is ferric thiocyanate, and D is ammonium chloride. Now you can see there is a state of equilibrium. Now let's change the concentration by adding some more reactant. What we have done there, we have increased the concentration of the reactant. So equilibrium will be disturbed. So no equilibrium. Now the system is going to oppose the change by reestablishing the equilibrium. So it will form some more product. Now it has attained the equilibrium. So new equilibrium will be established back. So this is how the system actually opposes the stresses. So next factor that we have is the pressure. And if your system in equilibrium involves only solids or only liquids, then pressure does not affect the state of equilibrium. However, if your system in equilibrium involves gases, then pressure actually plays significant role in the state of equilibrium. This is because the pressure can change the concentration of the components. So let's see here. You have nitrogen and hydrogen reacting to give ammonia. So you have 1 mole of nitrogen, 3 moles of hydrogen, giving us 2 moles of ammonia, and in reactant side we have 4 moles there. So now the volume at the reactant side is larger than the volume at the product side. And let's say the reaction has taken place. Now it has attained the state of equilibrium. Now let's add the stress. So what is our stress for now? We have pressure. And how can we increase the pressure, or how can we decrease the pressure? Because the volume and pressures are inversely related. So if you decrease the volume, definitely the pressure is going to increase. You might have observed in your lives, for example, if you try squeezing the balloon, the balloon actually bursts out. This is because when you squeeze the balloon, the volume of the balloon becomes smaller and the pressure increases. That is how the balloon actually bursts out. So let's increase the pressure here. So for that, let's say initial pressure is 2 atm. Now we want to increase the pressure by decreasing the volume, and before that, let's say the amount of ammonia produced at 2 atm is X. It can be X gram, it can be X moles, or it can be X kg or tons, it can be any unit. And let's decrease the volume there. And when you decrease the volume, actually we are increasing the pressure. So pressure has become 4 atm. Now system is stressed. System at equilibrium is disturbed. System will overcome the stress by producing some more ammonia, and the amount of ammonia that we have produced will be double of what we have before, because we have increased the pressure by double. And the next factor that we have is temperature. And in reversible reaction, you should know that there are 2 opposing reactions. One that is taking forward and another that is taking backward. And if one of these 2 reactions involves release of heat, which we also called as exothermic, then definitely another will be endothermic. So now let's look here. From there you can say that that reaction is endothermic in nature, meaning the product has absorbed some more heat energy. That is why that reaction can be categorized into endothermic reaction. And you have dinitrogen tetroxide, which is colorless, and it has decomposed to give us brown nitrogen dioxide. If we put this dinitrogen tetroxide in a closed container, and this is going to decompose, and it is going to give us nitrogen dioxide, which is brown in color. So just now you can see the brown color because of that nitrogen dioxide. Now let's try increasing the temperature. Since the reaction is endothermic, so if we increase the temperature, it favors more production of the brown nitrogen dioxide. So let's increase the temperature. So the intensity of the brown color also increases, indicating more production of nitrogen dioxide has taken place. Now if you decrease the temperature, the backward reaction has occurred actually, meaning more of that colorless substance is produced. That is why the intensity of the color has decreased. So this is how temperature actually affects equilibrium. In this case, increase in temperature favors more production of nitrogen dioxide, and decrease in temperature favors backward reaction, meaning more production of dinitrogen tetraoxide. And as I promised in my earlier presentation, that I am going to tell you the importance of chemical equilibrium. Actually, chemical equilibria are important in biological and environmental processes. What is this? You must have visited this type of sites before. Actually, it is a formation of stalagmite and stalactite. We also commonly call it as limestone caves. So here there is the involvement of chemical equilibrium. So what happens is, when the limestone containing rocks meets with the acid rain, then this limestone is going to decompose into calcium bicarbonate, and calcium bicarbonate is fairly water soluble, and it dissolves in water and seeps down. It gets accumulated in the ground. Now as the concentration of calcium bicarbonate increases, there is a disturbance in its equilibrium. So the reverse reaction will take place now, because the concentration of the calcium bicarbonate is more. So the reverse reaction takes place, and this substance actually precipitates to give back calcium carbonate. So this substance actually precipitates to give back the calcium carbonate, which we can see as stalagmite and stalactite. Then another importance of chemical equilibrium is in breathing and oxygen transport. So for your information, as we actually breathe in, so in each breath we take in about 500 ml of air, and this 500 ml of air goes through our lungs and it gets distributed to 150 million alveolar sacs. It gets and mixes with the blood, and only 3% of the oxygen in the blood is dissolved. Rest, it will chemically bind to hemoglobin molecule. Actually, hemoglobin molecule, it is a large protein which contains 4 hemigroups. So this one is one hemigroup, and in one hemoglobin molecule you will have this type of 4 structure, 4 molecule substance hem groups, and each hem group is capable of binding, capable of holding one oxygen molecule. So which means one molecule of hemoglobin can hold 4 oxygen molecules. So this is how the binding will take place. Hem group bound to 4 oxygen molecules, and in hot working conditions, when some part of our body actually perform extra work, so that part becomes oxygen deficient. So there will be lack of oxygen that time, because the tissues and muscle, because of extra work, has used extra oxygen. So that is the time that the compound of hemoglobin and oxygen molecule will reverse the reaction and give back the oxygen molecule. It will replace the oxygen molecule. Another example of chemical equilibrium is, why does the wet cloth dry when it is windy? Or why do we move the cloth to make it dry faster? Or why do we put the fan on in order to dry the cloth faster? So there is the importance of equilibrium playing here. Actually, what happens is, when you move the cloth or when there is fan moving on, so the water molecule around this wet cloth will be blown away. So there is a disturbance in equilibrium. You have more amount of water in this cloth, whereas there is the water vapor that was around the cloth is blown away. So there is a disturbance in equilibrium. Now the system will reestablish the equilibrium by releasing the water from your wet cloth to the surrounding. So that is how your actually cloth paste dries faster when it is windy or when you put on the fan. So let us look at the application of Le Chatelier's principle. So Le Chatelier's principle can be well used in formation of sulfur trioxide, and this sulfur trioxide is used further to prepare sulfuric acid, which is known as contact process. And sulfuric acid is one important chemical compound we also called as king of chemicals. King of chemicals. And why do you think sulfuric acid is known as king of chemicals? Because in industries, sulfuric acid is used to manufacture varieties of other chemicals. That is why sulfuric acid is also known as king of chemicals. So this is the process of preparing sulfur trioxide, and if you want to produce more sulfur trioxide, first you will have to look at the conditions like pressure, concentration and the temperature. So you have 3 moles in reactant site and 2 moles at product site. So let us look at the factors that favor more production of sulfur trioxide. The first factor is the concentration. If you increase the amount of sulfur dioxide or oxygen in reactant site, definitely that is going to give us more product. For example, let us say it is at equilibrium. You can either add sulfur dioxide or oxygen at reactant site, or you can also remove the product, that is sulfur trioxide. So that is how we can stress the system. Now the equilibrium is going to be disturbed, and it reestablishes the equilibrium by producing more amount of sulfur trioxide. Another factor that can favor more production of sulfur trioxide is you can lower the temperature, because the reaction is exothermic in nature, meaning when this reaction happens, it is going to produce the heat. So there is no need of heat. If you increase the temperature, then there is no use, because it is exothermic in nature. Therefore, low temperature actually prefers more production of sulfur trioxide. And the last factor that will favor more production of sulfur trioxide is high pressure, because the volume at reactant site is larger than the volume at product site. You say 3 moles at reactant site and just 2 moles at product site. So what we can do is we can decrease the pressure. So concentration is altered, equilibrium is disturbed. So to maintain or reestablish the equilibrium by producing more amount of sulfur trioxide. And likewise, So you can also predict the factors or conditions that will favor more production of nitric oxide. You just try yourself. And we have formation of ammonia, Haber's process. So how can we produce more of ammonia since the reaction is reversible? So you can just predict yourself. Once you know whether the reaction is exothermic or endothermic, we can easily predict the condition for more production of the yield. And with this, I have the home assignment for you. So I want you to state Le Chatelier's principle. So I have the reaction, 1 mole of nitrogen combines with 1 mole of oxygen to form 2 moles of, actually it should be 2 moles of nitric oxide. So which thermochemical reaction does the above reaction represent? And state and explain the factors that favor more production of nitric oxide in the above reaction. So with this, thank you for being with me.